Cheryl and Jackie work at an ice cream shop. Cheryl earns $9.25 per hour, and Jackie earns $8.75 per hour. During a typical week, Cheryl and Jackie earn $334.75 together. One week, Jackie doubles her work hours, and the girls earn $466. How many hours does each girl work during a typical week? So anytime we have a word problem like this, the first thing we do is define our variables. And usually the variables that we need to define are found in the question, which was how many hours does each girl work? So we've got two here, Cheryl and Jackie. So let's say C is the number of Cheryl's hours. And for Jackie, we'll do K. I'm just kidding. We'll do J for Jackie's hours. Number of Jackie's hours. Okay. And so in both of these equations that we're going to write, it gives us a total amount of money, right? The first equation is going to be that they earn 334.75 together. And then in the second equation, Jackie gets more hours and they earn 466. So all of these are going to be based on money. So we're going to do their hourly rate times their number of hours for both equations. So Cheryl earns 9.25 an hour. So for our first equation, let's do $9.25 times however many hours Cheryl works, plus $8.75 times however many hours Jackie works. And it says in that week they make $334.75 together. So there's equation number one. Equation number two is going to look very similar, except it says Jackie doubles her work hours. So normally Jackie works J hours because we said J was her number of hours. But if she's doubling her work hours, now we're going to say Jackie works 2J hours. Normally she works J and she doubles them. Double is 2J. So neither one of them is making more money, right? So Cheryl is still 925 times however many hours she works, and Jackie is still 875 times however many hours she works. But instead of doing 875 times J, we're going to do 875 times 2J because Jackie doubles her hours, and the problem says they make $466 together. Okay, this is a problem that is absolutely one we should solve using the elimination method. And the reason that I say that is because our coefficients for Cheryl's hours are the same. They're both 925. You might be looking at Jackie's and say, wait, Jackie's coefficients are the same too, aren't they? And the answer is no, because the first thing that we're going to do is this 875 times 2J, which is going to change the 875 so that they won't have the same coefficient. So let's rewrite the first equation, making no changes. So the first equation exactly the same. And then underneath that, we're going to write the second equation with that multiplication done. So the second equation, still 925c, but now we need to do 875 times 2, which is 17.5. And that equals 466. So it may have looked like they both have the same coefficients, but after we do some simplification, now the coefficients aren't the same anymore, and we have to use the C variable for our elimination, which is fine. Not a big deal to use C. So let's go ahead and subtract these two equations. And the reason we're going to subtract is because 925c minus 925c is 0. So that's going to completely eliminate our c's. And I'm going to get a calculator here to do my decimal subtraction. Even if you feel pretty confident that you could do it without a calculator, I mean, just buckle down and use the calculator for God's sake. You don't want to do all of the algebra perfectly and then get a wrong answer because you were too proud to use a calculator. So 875 minus 1750, of course, is 875. I mean, if 875 times 2 is 1750, then subtracting 875 is going to give us that same thing. And then we'll do 334.75 minus 466. And that gives me negative 131.25. And now we're one step away from figuring out how many hours Jackie worked. And that one step is the division property of equality. Divide by negative 8.75 and divide by negative 8.75. So the division property of equality is going to tell us that Jackie worked negative 131.25 divided by negative 8.75 is 15. Jackie worked 15 hours. 15 hours in a typical week. This is the second week she doubled her hours and she had 30, obviously, but the question says typical week. So in a typical week, Jackie works 15 hours. Okay, so how many does Cheryl work? Well, for that, we're going to take one of our equations that we have and plug in 15 for our J and then solve for C. We can use any equation we want to. So if we can use any equation, I think it is perhaps wise to use the equation that has the smaller numbers, which is going to be the first one. 925C plus 875 times, and then we're going to plug in our 15. Equals 334.75. There we go. All right. So first let's do some simplification. Let's do our 875 times 15. So 8.75 times 15 is 131.25. Boy, I feel dumb typing that into the calculator. Of course it's 131.25 because we got 15 by doing 131.25 divided by 875. Use your head, Taylor. Oh, and then I wrote two equal signs. How about that? I would say, oh, it's getting late and I'm tired, and that's why I'm making mistakes, but it's 5:25 in the afternoon, so it's not that late. So let's go ahead and use the subtraction property of equality. We'll subtract 131.25 on both sides. And we get 925C. So we'll do 334.75 minus 131.25. And that gives me 203.50 or 203.5 after using the subtraction property of equality. So then the final step is the division property of equality. We'll divide by 9.25 and again by 9.25. And my calculator says 203.5 divided by 9.25 is 22. Okay, so now we know how many hours they worked in a typical week. I'm going to go ahead and write that out as a sentence. In a typical week, Cheryl works 22 hours and Gerald, I forgot Jay's name. What was Jay's name? Jackie. And Jackie works 15 hours. So 22 hours and 15 hours. And again, the easiest way to solve this once we wrote the equations was clearly elimination. And the reason it was clearly elimination is because the coefficient for our variable c was the same in both equations.